Okie dokie. Once again, we've got an application question. Here, what they do is they give us an equation, and we've got to work some stuff out based on it. So it tells us a helicopter, the height, its altitude in meters, is given after t seconds, after it begins its descent, is given by this. So if we were to draw this, let's start off by drawing this. So the height, h, and we've got time, t. So if we have a look at this, we have a look at that there. Now, when t is equal to 0, what is its height? Well, its height is 350, so it's going to be here. So we're at 0 and 350. And now that answers one of the questions already. What is the helicopter's initial altitude? It's there. And it's telling us that it is descending. It is descending. So over time, it's going to do this. Going to do something like that, but we don't know. We don't know where it ends, or we can work out where it ends, but it doesn't ask us to do that. We just know that's what the graph asks us to do. So if we here at 0 and 350, what is happening every second? This tells us what's happening every second. So every second, its gradient is negative 20. That tells us that for every second, it's going down by 20 meters. So here we're at 1 and 330. Then over here we're at 2 and 310. Then over here, we're at 3 and 290, and so on. That's what's happening there. So, what we can say to answer this question A, at what rate is the helicopter's altitude decreasing? Well, it is decreasing at 20, oops, wrong one. It is decreasing at 20 meters per second. Or we can write it as 20, let's write that clear, it looks like milliliters, or milliliter seconds. 20 meters per second. We can also write that as meters per second -1. This means the same thing. B, what is the helicopter's altitude increasing? So that is negative 20 meters per second. So it's definitely decreasing, so it's decreasing at a rate of 20 meters per second, but its altitude is increasing at a rate of negative 20. So it's just the opposite. So they're just trying to be a bit funny, I think. Okay, question C, we've already got that. That's at 350 meters. How long will it take the helicopter to reach the ground? Well, what's our ground? What's our height? Our ground level height. That's 0. So let h equal 0. And then we solve. So I'll say 350 minus 20t equals 0. So we're going to take this 20t over to the other side because I don't like working negatives. So 350 equals 20t. So we're going to end up with, 17.5. So t equals 17.5. So it's going to take 17.5 seconds to reach the ground. As we've got there, and this is D, not C. Okay, on to the last question. If the rule was 350 plus 20t, describe what the helicopter would be doing. Well, here we've got this, we got 350, so 0 and 350. If it's plus 20t, after 1 second, we're going to be here at, not 0, we're going to be at 1 and 370. And then we're going to be at 2 and 390. And so on. So what's actually happening there is that it's increasing. So it will be increasing at 20 meters per second. And that's all that we've got to do for this type of thing here. So we look at our equation, might be able to draw a graph straight away. Draw a graph. Work that out, find a couple of points, just draw a graph. There's some marks for you already. Then from there, it's about interpreting what the question is asking and going from there.